So we started with the general properties of the wave, the mod, the way by which energy transfer from one place to another. And there are many examples in our daily life. We have water waves, sound waves, electromagnetic waves such as light waves, infrared radiation, or X-rays. There are many types of waves. Then two basic classes of the wave. One is called transverse wave. Transverse wave means the wave in which the particles move perpendicular or 90 degree to the direction of the wave. And the second one is a longitudinal wave in which the particles move same as the direction of the wave. For a transverse wave, we define certain terminologies. Number one, crest. The highest point of the wave are known as crests. The lowest point of the wave are known as troughs. The distance between the two successive crests, that's called wavelength. Same thing, the distance between the two successive troughs, that is also known as wavelength. Or length of one wave means length of one complete crest and one complete trough horizontal. This total length is also known as wavelength. The SI unit, because it's a length unit, SI unit of length is meter, and it is denoted by a Greek alphabet lambda. So example, if I say length of this wave was say 2 centimeter. So what I will say, the wavelength is 2 centimeter, and how I write this, I will say lambda is equals to 2 centimeter. Is it clear? This is the wavelength or length of one wave. Then the distance from the center of the wave to the highest point, either a crest or a trough, this distance is known as amplitude. So if we have a wave, a transverse wave, and this is the center point of a transverse wave, and I say label A, B, C, and D. This one is A, B, C, and D. What is A here? What does letter A represent? So A is representing a wavelength. So A is actually a wavelength. What letter B stands for? The distance from center to the maximum position, we call that as amplitude. So B stands for amplitude. Because I asked label the arrow that's representing amplitude. What arrow label C stands for? C is a trough. And what D stands for? D stands for crest. So these are the points which we define for a transverse wave. The amplitude of a wave is a maximum displacement. So example, a transverse wave example is given, the water waves are there. So highest point is called crest, lowest points are trough. The distance from center to the highest maximum position is amplitude, and this is the direction in which the water is transferring energy. Wavelength, a distance between the two successive crests or two successive troughs, or the distance of one complete wave is known as wavelength. Because crest and troughs are easy to identify, that's why we use distance between two successive crests or trough. But it can also be the distance of one complete wave or length of one complete wave. That's also called wavelength. Is it clear for a transverse wave? For a longitudinal wave in which the particles travel parallel to direction of the wave or vibrate parallel to direction of the wave. So what you observe, you can see here in this picture, when the particle, the cone speaker, this speaker cone is causing a vibration to the particle. So there are some places where the particles are very close to each other. And there are some regions where the particles are away from each other. So in a longitudinal wave, the region where the particles are very close to each other, that region is called compression. Compression, the region where the particles are very close to each other. And a rarefaction, where the particles are away from each other. Rarefaction is the same term, can be used for expansion. So rarefaction or expansion having a same meaning. So you can see in this region, the particles are away from each other. So they are like, it appears that the part is expanded. Which one you think will have high pressure, compression or rarefaction? Which one you think will have high pressure? Which region, compression or rarefaction? The compression will have high pressure because the particles are closer to each other, so they will collide more often and they will exert more pressure or high pressure. And rarefaction, particles are away, so they will exert less pressure. Is it clear, the concept of longitudinal wave, in which you can see here, Yusuf, the particles are closer, so particles can collide easily, so they can exert more force. So as they are exerting more force, means they will exert more pressure. But in this region, the particles are away from each other, so they cannot collide with each other easily. That is why this region will have low pressure. So in a longitudinal wave, you will always have a compression and rarefaction. So you can see here, the second graph is for pressure. It's not the wave, it's for pressure. You can see as this compression, the red part is traveling, the pressure is high and it travels from one place to another. You can see the red part where the pressure is high, that's compression. And the rarefaction where the particles are away from each other. So this part is rarefaction. So if I say label on this graph, a compression and rarefaction. So on this graph, where the pressure is high, that's compression. And where the pressure is low, that is rarefaction. Is it clear? This is a graph. This is not the wave. This is a graph to show a variation of a pressure in a longitudinal wave. So in a region of a compression, the particles are closer, so pressure is high. And in a region of rarefaction, the particles are away and the pressure is low. You can see here, this is a sound wave. Example, you have a tuning fork and you're producing a sound. Can you identify which wave is this, longitudinal or transverse? Which wave is produced here, longitudinal or transverse? This is a longitudinal wave. How you identify it's a longitudinal wave? Because when you check the movement of the particle and the movement of the or energy transfer, they are same or parallel to each other. That's why it is a longitudinal wave. So even in this region, the compression where the particles are closer and a rarefaction where the particles are away. And the wave transfer energy from one place to another. So when we produce a sound, basically what we cause the air molecules to vibrate to and fro and transfer energy from one place to another. The region where the particles are closer, it have a compression, and the region where the particles are away, that is called rarefaction. For the longitudinal wave, we also define wavelength. So what is the definition of a wavelength for a longitudinal wave? And before that, the definition of compression. So compression is a region where the particles are closer and high pressure. Rarefaction is a region where the particles are further apart and the pressure is low. And the distance between the two successive compression, this is one compression and this is another compression. So the distance between the two successive compression, that is called wavelength, or the distance between the two successive rarefactions is also called wavelength or length of the wave. Then what is the term frequency means? Frequency means how many vibration produced in 1 second. Number of waves or number of vibration produced in 1 second, that is called frequency. So if I show a picture in which the vibration is produced, so in 10 seconds, this is a 10-second timer. So how many vibrations are produced in 10 seconds? Can you identify? If I start the timer, how many vibrations are produced? Look, to identify this, the timer start like when it going down and returning back, that is one. Don't see the whole wave, just focus on one part of the wave, like focus on this side. How many times they are going up and down, that is going down and returning back, that is one vibration. So don't see the whole wave, just focus on one particle. I will show again. Look, now it start. Just focus on one particle. How many times? It's actually vibrating. No, focus on one particle. Like if I say focus on this particle, I'll show again so that you can identify. Only focus on this particle, how many times it vibrates in 10 seconds. Now start. So how many times it vibrated in 10-second timer? It's actually 10. 10 is the right answer. So it vibrated 10 times in 10 seconds. But what is the frequency? The term frequency means number of vibration in 1 second. So number of vibration per second or vibration divided by time. So vibration, how many vibrations are there? 10. What is the time interval? 10. So 10 divided by 10, what is the frequency? The frequency is equals to 1 hertz. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So actually it vibrated 10 times in 10 seconds. To get the frequency, it's vibration divided by time. So we'll get the number of vibration in each second. So the answer will come out 1. So the frequency of this is 1 hertz. It means it is vibrating 1 time in 1 second. What about the second one? It will be fast, so maybe you find it difficult to identify, but try. Just focus on one point, one particle, and count the number of vibrations. So how many times it vibrated in 10 seconds? Because this is a 10-second timer, means after 10 seconds, the timer will stop. It's about 14 vibrations in 10 seconds. So if I need a frequency, it is vibrating 14 it is having 14 vibrations in 10 seconds. I need frequency. Frequency means number of vibration divided by time. So there are 14 vibration divided by time, which is equals to 10. So what we get 1.4 hertz. Now, what about the third one, which is a slow vibration you can identify easily? What about the number of vibration third one? How many vibrations in 10-second timer? Yes, it is 5 vibration. So actually it's 5 vibrations in 10 seconds, but the frequency means number of vibration per second. So it will be 5 divided by 10, which is equals to 0.5 hertz. Hertz, in short, you can write Hz. Is it clear? The concept of a frequency, it means how many times a particle vibrate or how many times a wave produce a vibration in 1 second. These are some like a main voltage waveform, a tuning fork wave, ultrasound scanner wave. Which one is having the highest frequency? 1, 2, or 3? The third one is having the highest frequency because more waves in 1 second. The term time period means how much time the wave will take to complete its vibration. So time taken by a wave to complete its vibration, it's called a time period. Like example, this is one complete wave. So how much time the wave will take to complete its vibration, we call that as a time period. And the relation between higher and lower frequency has a relation with energy, not with speed. So if it is less time, yes, it will have a higher frequency. So the relation between the time period and a frequency is inverse. If the wave is having the highest frequency, it will take short time to complete its vibration. So in this wave, which is having the highest frequency, as you mentioned, third one is having the highest frequency. Which one is having the shortest time period? Shortest time period, like take less time to complete vibration. So third one is having a shortest time period. Same thing, if you have a main voltage supply here, this is having the lowest frequency in this example. And having the highest or longest time period. So if the wave is having higher frequency, it will have a shorter time period. If wave is having a lowest frequency, then it will have the longest time period. So they're inversely related. This is just the first one is for which animal? As sound increases, then decreases. No, this you cannot know. It's just a example. You don't have to learn the waveform, just an idea. Why the third one you're not able to hear anything? Like you are able to hear this sound for the cow. The second one is for baby crying, but what about the third one? So why we are not able to hear? Yeah, that's correct, Abdullah. Because we cannot hear all this. We cannot hear all the sound, or we cannot record all the frequencies. The frequency which our ear is sensible or detect, it's from 20 hertz to 20,000 hertz. So bats are producing a frequency more than, it's more than 20,000 hertz. That's why we are not able to hear it. So either it produces a frequency less than 20 hertz or more than 20,000 hertz. That's a normal human ear can record. You don't have to learn this. This is just for an example, like an identification. Which of the points are exactly one wavelength from A? Which point is one wavelength, one complete wavelength from A? Answer is E, that's right. The highlighted letter to one wavelength away. D and next to D, which one is one wavelength away? So with D, the one wavelength away is P. Yeah, P is the right answer. For the next one, with J, which one is one wavelength away from J? Yes, V is the right answer. Which one is one wavelength away from B? Which one is one wavelength away from B? N is the correct answer. Because you can see here the one wavelength distance from D was P, then C will be O, and then B will be N. Which one is one wavelength from M? X or A? It's not, you can select a point before that also. There should be one more point for the X. Actually, it's A is the right answer, because there should be one more point after X. It's actually A. Yes, even it is going towards right, but the thing is you can select the question was select a point which is wavelength away from this. So there should be another point Y. If there was another point Y here, then that point is also one wavelength away. But Y is not given, so that's why A is the right answer. So distance from mean position to extreme position we call amplitude. Match the waveform of the sound. This is just an exercise to understand. Or leave this, it's then how we can find the speed of the wave? Speed of the wave is the distance traveled by wave in a specific time. So there are three formulas to calculate the speed of the wave. Speed is and wave does not accelerate. So distance traveled by the wave In unit time, we call that as speed. Speed of the wave is having three formulas depending on the question. Without reflection, if there is no reflection, then the formula for speed is equals to distance divided by time. If there is a reflection, the wave travel and bounce back, then the formula is for a speed is equals to twice the distance divided by time, because it is going and coming back. And if speed, frequency and wavelength are given, so if the frequency and the wavelength are given, then the formula of speed of the wave is equals to frequency multiplied by wave length or the length of the wave. So these are the three formulas which we will use. The term reflection means, look, for example, you're standing at position A and your friend is standing at position B and you shout towards your friend, so your sound travel from A to B. So in this example, there is no reflection, but you are standing at position A in front of the wall and you produce a wave. When you produce a wave, your wave travel and then it hits the surface and bounce back. So when the wave changes the direction or bounce back, we call that as reflection. So if there's a reflection, then the formula for the speed of the wave is speed is equals to 2 multiplied by distance, because it is going and coming back, divided by total time interval. And the last formula, if the frequency and the wavelengths are given, if I give you the wavelength example, wavelength is 2 meter and frequency is 3 hertz, and you want to find the speed of the wave, how you can find speed of the wave? Multiply frequency with the wavelength. So it will be 6 meter per second. SI unit of speed is meter per second, so we will get meter per second.
Sir?
Yes?
Yeah, I have a question. Will it be mentioned in the question in the exam that there is a reflection or if there is no
Yes,
reflection?
in the question, they will specify that wave bounce back or the wave travel from one place to another. They will specify this. Or
Okay, thank
either
you.
a figure will be given. A figure will be given. You can identify from the figure that whether a wave is actually bouncing back or it travel from one place to another.
All right.
So some example questions I want you to attempt. The diagram below shows how the displacement of the water waves vary with the time. The wavelength is 8 centimeter. State the amplitude. What is the amplitude of this wave?
+2.
Yeah, amplitude is a scalar quantity, so you don't have to specify a direction. But so it is, you can mention 2 millimeter. The unit of the y-axis is millimeter, so you have to use the millimeter here. Next is calculate the frequency. Frequency, how many vibrations are there in 1 second? That's called frequency. So formula to calculate frequency, frequency means vibration divided by time. How many vibrations you see in the picture? How many vibrations? Look, this is one vibration. one wave, two waves, and 2.5 waves. Look, vibration, how many waves? This is one wave, two, and 2.5 waves. The total number of waves divided by time, because wave is a vibration, so this 2.5. And what is the time given here in the question? How much time they're taking? The 2.5 vibration, it's taking 1.25. So 2.5 divided by 1.25, what we will get?
2.
2 hertz. Is it clear? So number of vibration in 1 second, that's called frequency. Or I can also use another formula. Frequency is reciprocal of time period. F is equals to 1 over T. What is a time period? Time period means time to complete, time taken by one wave. So one wave, how much time one wave is taking? It's taking 0.5 seconds. So if I need a frequency, frequency is reciprocal of the time period. So 1 divided by 0.5, which is also equal to 2. So I can use number of waves divided by time, or I can use reciprocal of a time. You'll get the same answer. So it's up to you what you find it convenient. Use that formula to get the answer. What is the speed of the wave? How to find speed? We have the wavelength 8 centimeter. If wavelength is in centimeter, speed will be centimeter per second. If wavelength is in meter, speed will be meter per second. So calculate the speed of the wave. How to calculate speed of the wave? We have the wavelength and we have the frequency. We'll multiply them. So because the wavelength was in centimeter, that's why it is 16 centimeter per second. If wavelength is in meter, then it will be 16 meter per second. Because the speed is equals to frequency multiplied by wavelength. So frequency is equals to 2 multiply wavelength is 8 centimeter. 2 multiply 8 is 16. Because wavelength was centimeter, so 16 centimeter per second. In the question, you can see there is no reflection either mentioned. So you will not use the reflection concept. Yes, that will also give you the same answer. Because the length of the wave, the wavelength, length of one wave divided by time taken by wave, you will get the speed also. Because what is the length of one wave? That's given 8 centimeter. And how much time it was taking? 0.5. So you use the formula distance over time. So distance was 8 centimeter and the time was 0.5. So 8 divided by 0.5, you will get the same.